Dear learners and viewers, welcome to the video lecture of our regular and executive MBA programs, BBA program and PGDM program offered by the School of Business, Bangladesh Open University. Today we shall learn about present and future values of annuities of our finance courses, and the topic includes what is annuity, what are the types of annuity, how does the concept of annuity work in different time frame, how does the annuity value determine. At first, we have to know what is annuity. Dear learners, we know that the deposit pension schemes of commercial banks or installment based purchases require the equal or fixed amount to be paid in some series of periodic payments. These types of periodic payments are known as annuity. So, a series of equal payments at fixed intervals over a specified period of time is called annuity. In general, the payments for annuities are assumed to take place at the end of each period. When the payments are made at the end of each period, these type of annuities are known as ordinary annuity. So, when the series of cash flow takes place at the end of each period, such type of annuity is called ordinary annuity. For example, here the payments are made at the end of each period. On the other hand, when the series of cash flow takes place at the beginning of each period, such type of annuity is called annuity due. For example, here the payments are made at the beginning of each period. Now, we shall see how the future value or terminal value of an ordinary annuity is determined. For example, if you deposit taka 100 at the end of every month for 6 months at a rate of 12%, then how much money will you receive at the end of the 6th month? How much you will receive can be estimated through calculating the future value of each deposit made by you by using the following timeline. You can see that in this timeline the deposits are made at the end of each period, and the first period deposit is calculated in the following way. and others year's deposit are also calculated by using the similar formula. So, at the end of 6 months, the future value of all deposits will be 615.20. Here the future value of an ordinary annuity for the period of n is equal to payment multiplied by 1 plus r whole to the power n minus 1 plus payment 1 plus r whole to the power n minus 2 plus payment 1 plus r whole to the power n minus 3, and similarly it will continue up to payment 1 plus r whole to the power n minus n, or we can write payment multiplied by summation 1 plus r n minus t, and t is equal to the number of year 1 to n, where FBAN means future value of ordinary annuity for the n number of period, PMT is equal to payment in each period, and R means interest rate. Alternatively, you can use the table of future value interest factor for annuity for any number of years n at different rate of interest r. Therefore, future value of ordinary annuity for the period of n for taka 100 for 6 months at a rate of 12% per annum will be taka 615.20. In some cases like rental for capital or any other lease, payments are to be made at the beginning of each period. In these cases, unlike our previous example, such calculation does not work since the cash flows are subject to some forms of interest coverage. These types of payments are basically annuity due, and the present value of annuity due is determined by the following way. Future value of annuity due is equal to future value of ordinary annuity multiplied by 1 plus r, or future value of annuity due is equal to future value of annuity ordinary multiplied by 1 plus r. So, the future value of an annuity due for 6 months will be taka 621.35. Timeline for future value of an annuity due of cash flow can be presented in the following way. In this timeline, the deposits are made at the beginning of each period, and the first year future value of deposit is calculated in the following way, and the other periods are calculated in the similar way. So, at the end of the 6th month, the future value of this annuity will be 621.35. Here the future value of annuity due is higher than future value of ordinary annuity by taka 6.15. At this stage of discussion, we shall attempt to determine the present value of an annuity. When the future value of annuity is expressed in its current worth, then this value of annuity is called the present value of an annuity. For example, if you borrow some money right now and repay it in some future equal installments, then this loan repaying in equal installments is basically annuity, and the amount borrowed at current period is the present value of that annuity. Suppose you borrowed taka 10,000 at the rate of 10% for 5 years to be paid equally in annual installments. You can find that the installment will carry both principal loan and interest repaid during the period, and the calculation can be presented in the following table. In this table, the column 1 showing the amount due and the column 2 showing the amount paid in each period, and the column 3 showing the interest paid at a rate of 10%, and the column 4 showing the principal paid, which is the difference between the column 2 and column 3, and the last is column 5 that is showing the balance remain in each period, which is the difference between the column 1 and 4. And the balance of each period is basically using here at the beginning of the loan balance in each period. So, at the end of 5 years, the loan balance will be 0. Here the table is showing the amortization of taka 10,000 loan in equal annual installments of taka 2,637.83 with interest component of 10%. In that case, the solution of present value of an ordinary annuity is derived as, here the present value of an ordinary annuity is equal to payment to be made in each payment multiplied by present value interest factor of annuity at a rate of interest I for the period of n, where PBA-N is equal to present value of ordinary annuity for the period of n. PMT is equal to payment to be made in each period. PBIFA-IN is equal to present value interest factor of annuity at the rate of R for the period of n. In our example, the present value of an ordinary annuity of taka 2,637.83 for 5 years at a rate of 10% interest will be, here the present value of an ordinary annuity for 5 years will be calculated by multiplying the annual installment with the present value interest factor at 10% for 5 years. So, the present value will be taka 10,000 and the present value interest factor at 10% for 5 years is 3.7908, which you can find it in your present value interest factor table for annuity. Now, we shall see how the present value of an annuity due is calculated. The present value of an annuity due is calculated in the following way. Here the present value of an annuity due is equal to payment multiplied by present value interest factor of ordinary annuity with 1 plus R, where PBA due is equal to present value of annuity due for the period of N, PMT is equal to payment to be made in each period, PBIFA is equal to present value interest factor of annuity at the rate of R for the period of N, and R is equal to interest rate. In this example, if the annuity is an annuity due, then the present value of that annuity will be, here the present value of annuity due at 10% for 5 years will be payment multiplied by present value interest factor with 1 plus interest rate. So, the present value of this annuity due will be Taka 11,000. Dear learners, so far we have seen how different forms of annuities are valued. The knowledge of annuity is of immense use for amortization of loan as well as savings plan of any individual. We hope that now you will be able to solve similar types of problems in your textbook, and for better understanding, please practice more and more. See you in another day with another topic. In the meantime, goodbye to all of you.